Welcome back, Algebra 2. Today we're on 5-3, inverse relations and functions. So what is an inverse relation or function? You get that when the set of ordered pairs obtained by exchanging the coordinates. So all we're going to do is flip x and y. That's all you got to do. All right, so given f of x is these three ordered pairs, find its inverse. Okay, so inverse, we are going to write as f negative 1 of x. So inverse is also written as f with this exponent of negative 1 and x. And all we're going to do is flip these. So in an ordered pair, it goes xy, xy, xy. So the inverse, all you got to do is take these and flip it. So that becomes 2, 1. This becomes negative 4, 3. This becomes negative 8, negative 5. So when you have ordered pairs, that's all you got to do is just flip the x and y. All right, so here we don't have a y. Well, what you got to know is that f of x and y, for all intents and purposes, means the same thing. So I'm going to switch whatever's in function notation to a y. So this one is going to be 4 minus 3x. When I get to this one, g of x, I don't really care what that letter is. It's all just going to be y equals. And that's going to be x minus 4 over negative 3. All right, so that's the first step. The next thing is that you're going to flip x and y. So this y, I'm going to write as x, 4 minus 3. This x, I'm going to write as y. That's all you got to do. Wherever you see the y, you put an x. Wherever you see the x, you put a y. And then we have to solve for y. So I have to solve for that term right there. So this is a two-step equation. So I'm going to subtract 4 from both sides. Then I have x minus 4 equals negative 3y. I want to solve for this y. This is multiplication. So I undo multiplication with division. I'm going to divide both sides by negative 3. So I have x minus 4 divided by negative 3. Those two cancel each other out, and y. And then this really isn't y, it's the process to find the inverse. So I'm going to swap that out, and I'm going to write this in inverse notation. And then I'm probably going to put this on the left and clean this up. So that's f inverse of x equals x minus 4 divided by negative 3. All right, let's go ahead and do number 2 while we're here. So we already got rid of our function notation. We put a y there. The next step is to flip x and y. So now we have x equals y minus 4 divided by negative 3. And then it says solve for y. So I have to solve for that variable right there. So it's trapped in the numerator here. This is division. We undo division with multiplication. So I'm going to multiply both sides of the equation by negative 3. That's how I can cancel out that denominator there. On the left side, you just have negative 3x. And now you just have y minus 4 on the right side. We always wanted to solve for y, so I'm going to add the 4 over. So I have negative 3x plus 4 equals y. And we would like to write this in inverse notation. So I'm going to swap that out. And this function is g. So I would write that as g inverse of x. And then I would probably clean it up and put it on the left. All right, so this function, if you notice and pay attention to them, that's the same as what you started with here. So when I started with this answer, did I get what I started with over here? Yeah, I did, because negative 3x plus 4 is the same. You can switch those and write it as 4 minus 3x. So when you take the inverse of a function and you get the other function, these are called inverse functions. So number 1 and number 2 are inverse functions. Because when you take the inverse, you get the other function. That's how you know that you have inverse functions. Like, oh, I wonder if 3 and 4 are inverses. I don't know. Let's find the inverse and find out. All right, so I'm going to get rid of h of x and replace it with y. And then you flip x and y. X equals y squared minus 5. And now I need to solve for y. So the first thing you have to do is you have to isolate that variable. I'm going to go plus 5 to both sides. X plus 5 equals y squared. You have to ask yourself, what operation will undo exponents? Taking the square root. So I'm going to take the square root of both sides. When you take the square root, you get two answers, a positive and a negative. The radical and the exponent cancel each other out. And I would rewrite this in inverse notation and probably clean it up. So the inverse of h of x equals the square root of x plus 5. I don't think that's going to work over here because I have the square root of x plus 5 minus 2. So I can already tell these are not going to be inverses. But let's see how you would do this. Replace k of x with y. Flip x and y. So you have to solve for y, but right now it's trapped here under a radical. You have to isolate the radical first, so your first move needs to be to add 2 to both sides. So I have x plus 2 equals the square root of y plus 5. Radicals and exponents undo each other. So here I took the square root. Now here I have to square it. So I'm going to square both sides. On the left, since you already had 2 terms there, you're going to have to put parentheses around it because you have to square this entire quantity on the left. You can't just square the 2 or anything. So when you have this, we need to multiply it out. So I have x plus 2 times x plus 2. The radicals and the exponents cancel. You get y plus 5. So over here I'm going to multiply, distribute, FOIL, whatever it is you like to call it. X times x is x squared. X times 2 is 2x. Move and distribute this one. 2 times x, another 2x. 2 times 2 is 4. I would probably combine like terms first to clean this up a little bit. So I have x squared plus 4x plus 4 equals y plus 5. The goal was always to get y by itself, so I'm going to subtract 5. X squared plus 4x minus 1 equals y. And once again, this is the inverse, so I'm going to swap that out, and it's k for inverse notation.